Hi. Now this is a slightly tricky question. Here you have a lot of terms, basically an infinite series, but there is a pattern to it. If this 1, we can think of it as 1 into 1 upon 4 to the power 0. Right? 1 upon 4 to the power 0 is nothing but 1. 1 upon 1 is 1. So now if you look at the apart from the bracket, the term that is getting multiplied, we have 1 upon 4 to the power 0, 1 upon 4 to the power 1, 1 upon 4 to the power 2, 1 upon 4 to the power 3 and so on. So if we want to write the nth term, this is first term, second term, third term, fourth term. So if you want to write the nth term will be a bracket into 1 upon 4 to the power n minus 1. That's going to be the term apart from the bracket here, right? This is 4 to the power. The first term has power 0, second term has power 1, third term has power 2, fourth term has power 3 of 4. So this will be power of 4 is 1 less than the term, right? What about the bracket now? In the bracket, we have only 1 here, then we have 1 plus 1 by 3, then we have 1 plus 1 by 3 plus 1 by 9 and so on. So inside the bracket, we effectively have a GP in of 1 with common ratio 1 by 3, right? So in nth term will have a GP of 1 plus 1 by 3 plus 1 by 9 so on till 1 upon 3 to the power n minus 1, right? Number of terms here is 1, number of terms here are 2, number of terms here are 3. So number of terms here will be n. And in these n terms, the first power of 3 is 0, the second power of 3 is 1. So it starts from 0, right? The power starts from 0 and we want n terms, so last power will be n minus 1, right? Okay, so this is what we have. So now let's try to simplify this. This is a GP with the common ratio of 1 by 3 and the first term as 1, right? So the sum of this GP will be, we know sum of a GP is a into r to the power n minus 1 upon r minus 1. So the first term here is 1 into common ratio is 1 by 3 raised to the power number of terms which is n minus 1 upon 1 by 3 minus 1 into 1 upon 4 to the power n minus 1. So this 1 can be ignored, 1 into anything is 1. So this becomes 1 minus 3 to the power n whole by 3 to the power n upon 1 minus 1 by 3 minus 1 is 1 minus 3 by 3 whole into 1 upon 4 to the power n minus 1. So let's first simplify this part. Let's remove this. So since obviously 3 to the power n is greater than 1 and 3 is greater than 1 here, so let's switch these, basically multiply with minus 1 in numerator denominator. So this becomes 3 to the power n minus 1 by 3 to the power n. So by 3 to the power n is this, and here also we can write it as 3 minus 1 by 3. So by 3 basically goes up and gets multiplied, and then we have 1 upon 4 to the power n minus 1. So 3 minus 1 is 2. So we have a 3 by 2 over here. So 3 by 2 times of 3 to the power n minus 1 upon 3 to the power n into 1 upon 4 to the power n minus 1. So now this can be even further simplified as 3 by 2 into 3 power n upon 3 power n is 1 minus 1 upon 3 to the power n whole into 1 upon 4 to the power n minus 1. So this becomes 3 by 2 times of 1 into this whole thing is 1 upon 4 to the power n minus 1 minus 1 upon, now 3 to the power n can be written as 3 into 3 to the power n minus 1 into 4 to the power n minus 1, right? So this whole term now becomes 3 by 2 into 1 upon 4 to the power n minus 1 minus 1 upon 3 times of, now these two have same power, the base will get multiplied, 12 to the power n minus 1, right? So this becomes now 3 by 2 into 1 upon 4 to the power n minus 1 minus this gets multiplied here, so 3 gets cancelled out, 1 upon 2 times of 12 to the power n minus 1. This is the nth term. This is the nth term of this series. Now let me erase this whole thing and I'll rewrite this thing again. So we had nth term is 3 by 2 into 1 upon 4 to the power n minus 1 minus 1 by 2 into 1 upon 12 to the power n minus 1. This is what we had. So now to understand things better, let me write few terms here. First term is 3 by 2 into 1 upon 4 to the power 0 minus half of 1 upon 12 to the power 0. Second term will be 3 by 2 into 1 upon 4 to the power 1 minus 1 upon 2 into 1 upon 12 to the power 1. Similarly, third term will be 3 by 2 into 1 upon 4 to the power 2 minus 1 upon 2 into 1 upon 12 to the power 2, and so on. This will go on. Now if you calculate the sum, as in if you add all these terms will get added, and you can take 3 by 2 common and you'll get 1 upon 4 to the power 0 plus 1 upon 4 to the power 1 plus 1 upon 4 to the power 2, so on till infinity, minus all these terms will also get added, so you'll take minus half common, and then you'll have 1 upon 12 to the power 0 plus 1 upon 12 to the power 1 plus 1 upon 12 to the power 2, so on till infinity. So basically this whole sum now comes out to be just the sum of this infinite series and this infinite series. So we'll have 3 by 2 into, the first term here is 1, so for the sum of an infinite series is 1 upon 1 minus the common ratio, right? So the first term here is 1 upon 1 minus, the common ratio is 1 by 4, right? We are dividing by 4, each term is getting divided by 4, so the common ratio is 1 by 4, minus you have a half into. Now this is also an infinite series whose first term is again 1 upon 1 minus, the common ratio here is 1 by 12. So this becomes 3 by 2 into 4 minus 1, the denominator is 3 and this 4 goes in the numerator, minus half of, we'll have 12 minus 1, the denominator will be 11 and this 12 will go in the numerator. So we have 3 gets cancelled out, 4 cancels out with 2, becomes 2. So this term simplifies to 2 minus 12 by 2 is 6. So we have a 6 by 11 over here. So we have 2 minus 6 by 11. So 11 into 2 is 22, 22 minus 6 is 16. So the sum of this whole series comes out to be 16 by 11. Option C is the right answer here. Slightly tricky question, you have to make a lot of adjustments and solve it.